Hi everyone, we're going to graph the greatest integer function. And the greatest integer function is the greatest integer less than or equal to x. That means you tend to round down. You always round down. And usually a good example of that is like if you're 20 years old and a third, say you're 20 years old plus 3 more months. If someone asks you how old you are, you don't say you're 20 and a third or 20 and a half. You just tell them your age. So you're rounding down to your age. And this one's a transformation of 2. So I'm assuming that you already know how on this one to graph the greatest integer function. So if you just do your parent function, it looks like this. I'm just going by 2's here to make the graph look nicer right now. And you should know what it looks like before you start on transformations. So there you go. And if you do this as your parent function, you're at 0, 1, 2, 3, and 4. This would be -1, -2, -3, and -4. So we have those right in there. All right. So basically, if this was the parent function, this would be 1, 2, and 3. So if I'm just going to do a quick little table of values, and I really only want to deal with quadrant 1 here. So I put 0. 0 maps to 1. 1/2 would be, and I'm just doing right now, I'm just doing just the parent function. I'm just doing the parent function here. 1/2 would just map back down. It would be 1/2 and you round down. Then you go to 1, that maps to 1, and so forth. 2 maps to 2. So when you have this 2 in front, all you're doing is multiplying your y value here by 2. So I'm going to multiply that by 0, this by 2, and this 2 by 4. So instead of my range being 1, 2, 3, I really have 0 and 1. This was 1, but now it's going to be 2. This is 4, and this is 6. So this would be -2, -4, -6. Now, as far as you making the graph more accurate, that's fine. But if you can just graph it generally, it makes it a lot easier if you can just fill in the values second. So basically, your domain is all real numbers. However, your range on this one is different. Usually we say the range is all integers, but this time it's just going to be y, such that y is an even integer. Or you could say on this one a multiple of 2. All right? You still have your y-intercept as 0, 0, and your x-intercept again is written as x, 0, such that x is in between 0 and 1. That doesn't change. What's going to change is your range. So let's just say we have any integer, and we put the n in front of our integer. So we're expanding it. So what's of x, sorry. So what's going to happen is we still have the same graph. Just graph it, and I'm just going to copy it down here. Just going to graph 2 here. All right. So basically, this is still going to be 1, 2, 3, and -1, -2, and so forth. But your n values are going to change. So this is going to be n, and then this would be a multiple of n. So this would be your next one. This would be your n plus n. All right? Or 2 times n. So your domain is still the same. Your domain is still all real numbers, but your range is going to be y such that y is a multiple of n. All right? And then your your y-intercept is the same, and so is your x-intercept. Your x-intercept is still going to be in between 0 and 1, not including the 1. All right. That's it. Thank you. Have a nice day. Bye-bye.